So we are back to more science, and so of course we have a question because we have lots of those in science. So the question for today is this: how does a change in volume influence the pressure of a gas in a sealed container? So anytime we have a question, we always try to formulate some kind of way to figure out the answer to that question through experimentation. So I want you to think about this question. I want you to think about how you might come up with the answer to this question, design an experiment. As you think about that, I want you to grab your lab notebook. You're going to write this question on the top of the next page in your lab notebook. I want you to also be thinking about what you're going to measure, what you're going to test, what kinds of things you're going to change in your lab experiment, and see if you can remember the terms that we use to describe those parts of the lab experiment. Okay, so pause now and add your question to the next page in your lab notebook. So hopefully you've added your question to your lab notebook and you came up with these terms. So independent variable and dependent variable. And hopefully again you remember what those mean. So if you think back to the question, think about what we are going to change. That will become our independent variable. And the question was, how does the volume impact or influence the pressure? So we're going to change the volume and measure to see what that does to the pressure. So in your lab notebook, you're going to record a series of volumes and pressures. This is the device that we used in class to measure these things. So this is a little computer, it's a little LabQuest, and it is hooked to a pressure sensor, gas pressure sensor. And we're going to pull back out the syringe that we had been using. We're going to start with a volume of 5 milliliters. So we have 5 milliliters of air inside this syringe. I'm going to connect that to the gas pressure sensor so that the pressure sensor is now measuring the pressure that is on that gas in the sealed container. And we've talked about what pressure is and what it means and how we get air pressure. So remember, those particles are bouncing around in there, hitting the sides of the container, and that force is causing a certain amount of pressure. So that pressure is currently measured at 98.6 kPas. So in your volume column, if you haven't added your data table into your lab notebook, you can go ahead and do that. In your volume column, you're going to go ahead and record that 5 milliliters and this pressure here, so 98.7 kilopascals. I'm going to change the volume, and as I do that, I'll tell you what volume I have in the syringe, and you can record that pressure. So feel free to pause the video if you need more time to record your data points. So again, started out with 5 and looks like now about 98.7 kilopascals. So I'm going to alter this volume of the gas, again in a sealed container. I'm going to depress the syringe and alter that to 3 milliliters. So in your volume column you have 3 milliliters, and you can read the pressure reading on the screen there. So 3 milliliters with that pressure reading. And now I'm going to move to 7 milliliters, so that's your next volume. Go ahead and pause and record your pressure reading. And then to 9 milliliters, so again your next volume, pause and record your pressure. Next is 11 milliliters, pause and record the pressure. And now 13 milliliters. Pause and record the pressure. And our last data point will be 15 milliliters. Pause and record the pressure. And if I did not say the right number of milliliters, so you saw where the syringe was, so you record the correct volume of that gas. Now notice what happens when I turn loose of this syringe. So I also want you to think about what is going on there. So those are your data points. Now go ahead and open up that Vernier graphical analysis that we've used before. Input your data points and see if you can figure out how these two variables are related mathematically.